Let's start. So the idea of this presentation is to give you like an overview of really like a hands-on use of OPC UA. This tells about a solution that we delivered actually well during the first 3 quarters of this year for the Valio for the material handling, and we did it in with the cooperation and got a lot of help with Beckhoff. But let's introduce ourselves first. So my name is Pyry Grönholm. I am currently since September CEO at the Prosys OPC. I also was the head of the project team for this material handling system delivery. And my background is as a software developer, and I've done like industrial connectivity software since 1998 when I started as a summer trainee at Prosys OPC. And please, Lari.
Yes, hello from my side. My name is Lahdensuu, and I'm working in Beckhoff Automation Finland and as an area sales manager in our Hyvinkää office. And additional to the sales responsibilities, I am responsible also for food and packaging industry. So I was from that part involved in this project as well. Yes, thanks.
Okay, and little background about the Valio. That's of course well-known company for the Finnish participants typically, but Valio is the brand leader and the biggest direct business in Finland. But in addition to the milk products, the Valio has also product lines that are made of oat and as well as like juices and soaps from fruits and berries and so on. To little bit understand the complexity of Valio MES, it is good to state that Valio is producing more than 1,000 products, and they have the size of the company is such that they have around 4,000 professionals. And of course, this is not only the factories, but also R&D is very important part of the Valio business. Then going to the actual project, the starting point was that Valio Suonenjoki plant had kind of like a pen and paper type of material handling system. So they were scaling, of course, like the raw materials for the batches they produced, but those were done more or less like manually, and then like also they just kind of pen and paper way like knew which dosages goes to which batches and so on. So the idea was to automate this process in such way that like that the whole process would be coordinated by the MES system. The MES integration is using in Valio always OPC UA, so that was of course the natural interface for this solution as well. And the other tricky requirement was that actually those warehouse areas were kind of hazardous areas, so they were classified as ATEX 2 or 22 areas. So either there was like dust or gases that were in risk to like explode or burn or start burning if there would be any sparks. So every component or device that would be delivered on those areas should be according to the ATEX, or should have like the ATEX certifications. Well, yeah, sounded pretty easy, but honestly, like we were struggling in the beginning a lot. First of all, these kind of ATEX and OPC UA gateways that for the scales where there were, first of all, there were no OPC UA gateways for the scales from the scale vendors, basically. And when we added the ATEX requirement, they didn't have either the ATEX like gateways. So basically, like we had to go and look solutions that would be like connected to the scale like analog values directly, and would also have like would also be ATEX certified. Also, it's just not the big components, but all the small components and in enclosures even had to be ATEX certified, like fuses. For example, the fuses were really like painful to find, so eventually we couldn't find the ones that we designed in the beginning. But when we changed the fuses, then we had to change the powers as well. So kind of like a domino effect everywhere. But for our good luck, Beckhoff was able to actually provide us a perfect solution. So the components were ATEX certified, and of course they have like the great OPC UA capabilities. And when we got and started to work together with Beckhoff to design this, like everything started to proceed much better forward. A little bit about the architecture. So it actually consists of three different like OPC UA like interfaced systems. One is the scale, which is connected to the panel PC, and of course the panel PC will be used in the actual scaling process. Then there is a handheld device which is used for the to choose the scaling tasks, but also to load the scale dosages to the process when the corresponding batch is manufactured or created. And then the third solution or is the MES, and there is like a separate MES gateway, which in principle like interface the MES like Oracle database processes to OPC UA, and all like of course the scale software and the handheld device software were made out of the scratch, and the gateway were there already, but it needed a lot of modifications. But now I hand over to Lari to little bit tell more about this Beckhoff part and why it was like such a good fit.
All right, thanks, Pyry. Yes, so I'll tell you a little bit how this this automation control part was solved in this project. And if we start from the components, here I have this system layout where in the bottom you can see the scale, and the scale is connected to the I/O terminals in the separate box, and then from this box we have a field bus connection to the panel PC where the software, TwinCAT software, is running, and then in this software we are providing the user interface for the operators, and as well the OPC UA communication to the MES. And in this project, what was the, I think, two main things when we think about the selection of or choosing the components was that all these devices were located in ATEX area in zone 2. It means that all components, like Pyry said, has to have this certification for this area. And another thing was that this scale, this protection class was this EXAI, IA, and it means that it is intrinsic safety device, and there is some specific rules how you can connect that kind of protection class to the automation system. So if you can take the next slide, please. So in this slide, it is explained a little bit how the different protection classes in this ATEX environment can be connected to the automation system. So on the right side, the bottom, you have this zone 0, which is the most hardest area, and you can have these EXIA devices on that area. But if you are connecting those to the automation system, so for the standard automation components or automation system, you need to have additional barrier, so that this barrier is taking care of this ATEX requirements, and after that barrier you can connect it to the standard automation IO system. But what we found out in this project was that we were able to connect this scale directly to the Beckhoff IO system by using our blue terminals, which are ATEX certified. So this scale, which was this protection class IA, we were able to connect it directly without any barrier to our IO system, and that was definitely much more convenient than looking for some additional barrier. Yes, next slide, please. And then this project, I think it was quite nice way to integrate this working in ATEX environment, and also to bring OPC UA into this system. And for this OPC UA, we've used this our TwinCat OPC UA server, and I will tell you a little bit more about this TwinCat OPC UA server next. So what is TwinCat OPC UA server? In TwinCat automation system, this OPC UA is a separate installation package, so it doesn't come with let's say standard installation package. So you have to download it separately from our website. It is free, of course, and then you can install it in the TwinCat environment to have this OPC UA capabilities in your system. And what you can do with the OPC UA server, basically you can read and write variables from the TwinCat system, and what you need to do is to define which variables are visible in the OPC UA interface. And there are basically three ways or three mechanisms how to have access to the data. And you have this data access, which means that it's real-time access to the TwinCat variables. Then you have a historical access, which basically means that you have a ring buffer there, and utilizing that ring buffer, you can also access to the historical data. And the third one is these alarms and conditions, and that one means that you can receive notifications and events and things like that. And of course, security mechanisms are supported in our OPC UA server, so that is really important nowadays that everything is secured. All right, next slide. Yes, and here is a small reminder that Beckhoff provides quite wide range of products where the OPC UA is utilized, and there are quite many different use cases where these products are used. So if you have interest to speak about these ones, please feel free to contact us either in this event or afterwards. So that was it from my side. Please go on, Pyry.
Thank you, Lani. So a little bit also about the handheld device I mentioned earlier. So this was also kind of like a easy choice to choose the handheld device because it was the only one that was available. So we were looking forward for a barcode scanner with Android and ATEX certification, and honestly, like with our requirements for the delivery times, like this was the only device available, so we went for that. What we did was that we developed pretty much from the scratch, like the user interface for the MES that like covered the scaling and the batch loading like processes. We did this in the Java programming language, as we of course knew that like we can use our own SDK for Android OPC UA clients, and it succeeded pretty well. Then a few words about the MES Gateway. So this is, well, one of the first ever OPC UA applications that we have made, like the first version. Of course, it's been leveraged for Valio like during the years quite much, and now we added this material management or material handling features on it. That's .NET application running on Windows Server, and now in this case, like it really was the or the main part, so it orchestrates all the transaction between MES panel PC and handheld device. And a few lessons learned, like of course I knew, but I think this also proves it that the OPC is truly like multi-environment. So in this solution we run apps in kind of embedded TrinCat. We run in Android platform, we run OPC UA on Windows platform. We also figured out that these OPC UA methods, they are really feasible way when you are working with the transactional like multi-device communication. So you kind of like can call a method and then it checks something, and you from another like or from, let's say, MES, and then it returns you the results. Then probably you can even do something like that. You push the data to the panel for the scaling, and then it returns to the handheld device or something. So really nice way to do it. Also, we of course learned that Beckhoff really had this when we need to do something for the ethics environment in future as well. So well, there is so much little nuances on this ATEX thing and regulations that whenever you think that now you got everything right, then you figure out that, well, you don't. But Beckhoff devices typically were meeting all the requirements. And the last one is that at the moment, really like the global shortage of components is real. So we needed to design based on what is available and then adjust all the plans according to that. Okay, thank you. Do you have any questions for me or Lari?